Good morning, everyone. Today is May 18th, and make sure you have your notes written down before we begin. If you do not, go ahead and pause the video. You should have a number 16 in the top right-hand corner. For our warm-up today, we are going to be doing systems. The reason why we're doing systems again is because we're actually going to be getting into systems with quadratics. So to start, it says use substitution or elimination to solve. So for the first one, I'm going to use substitution because this x has a coefficient of 1 in front of it. If I go too fast for you guys, go ahead and pause the video and rewind and listen to what I say again. So I want to take this first one and I want to solve it for x. So how am I going to do that? I need to move this negative 7y. What's the opposite of that? I'm going to add it. So I get x equals positive 7y plus 11. Now I'm going to take this 7y plus 11 and I'm going to go into my next equation and plug it in for x. One correction that I did make, this should be a 9 instead of an 8 on your paper, so go ahead and fix that. Okay, now we're going to plug it in. 7y plus 11, make sure you still have that 2y on the outside, and that equals negative 19. I distribute, which means I multiply. 35y plus 55 plus 2y equals negative 19. I combine my like terms, which is 37y plus 55 equals negative 19. I'm going to move this 55 to that negative 19, and how do I do that? I'm going to subtract it. So I'm going to come up here because I'm running out of room. 37y equals, what am I going to do with negative 19 and negative 55? I'm going to add them because they're the same sign, and that gives me negative 74. And then my last step, I divide, and I get y equals negative 2. Now that's only my y coordinate. I got to plug this into this guy to get what x is. So plug in negative 2 in for the y. So we could do this in our head. What's 7 times negative 2? That's negative 14 plus 11. So x is negative 3, y is negative 2. Final answer. The second one, 6x minus 5y equals 8, and negative 12x plus 2y equals 0. Now this one, it would be a little bit trickier to do substitution, but you still could do it as always. But I'm going to choose to do elimination just so you guys can see both options. Elimination means I need to pick one variable and make it have the same number but opposite signs. So hopefully you see that x is going to be a little bit easier because we can make this 6 easily become a positive 12, which is the opposite of 12. So I'm going to take that entire top equation and I'm going to multiply it by 2. Then I'm going to write it right below. Now I'm going to add them up. My x's cross out. So I then have negative 8y equals 16. Divide by negative 8. And I get y equals negative 2. Now I need to plug it back in to get what x is. So let's just pick the top one because it's smaller. So we've got 6x and then negative 5 times negative 2 equals 8. So that's 6x plus 10 equals 8. Subtract the 10. I get 6x equals negative 2. Yes, this is okay. You're getting a fraction. It is what it is. You're not graphing it. No big deal. I reduced it to negative 1/3. So my final answer for this one is negative 1/3 comma negative 2. Okay, now like I said, the reason why we did this is because our notes are going to be systems of quadratics. So it says, in example 1, which value means the systems are true? Okay, so you see I have a parabola. Remember, my graphs are not the best. That parabola matches with this equation right here because it is a quadratic. This line, which is linear, matches with this equation, which is a line. All it wants you to do is to tell me where they're equal. What equal means is where they connect. So there are 2 points here that they connect, right? Or cross, you could say. And those are what they're looking for. So we then have to write those as coordinates. So this is just your visual representation of what we're going to be doing algebraically on the back. So my first coordinate, what does that say? Well, that's to the left 3, and I go nowhere, so -3, 0. Then I don't go left or right, but I go up 4. So they cross at those 2 points. I want you to go ahead and try example 2 now. So they cross at, what is that, -1, 0. And this is 3, 1, 2, 3, 4, 5, 6, 3, -6. Again, because you kind of just sketch these out, it's a guesstimate, but the point was to see that a parabola crosses a line. That's the visual representation. Now on the back, we're going to actually solve them. So again, you should have these written down. If not, go ahead and pause the video. So I'm going to read the directions. It says, find the solutions to the following systems by setting the 2 equations equal to one another. Okay, so you have f of x and g of x. Let's set it equal to